The purpose of this video is to go through the notes for lecture number 5, talk about the old exam questions and so forth that are in this set of notes. So again, we talked about ethics, and then we went back to systems thinking. And again, this material appeared on the 2012 final exam. So we have the opening of an article from Huffington Post, and you can read it there. This is an example, right? We have this situation where global warming melts the ice, and that reduces the reflective surfaces and increases the amount of sunlight that is absorbed by land and water, heating the earth, melting the ice even more, so on and so forth. So this feedback loop would be a reinforcing feedback loop. We're spiraling out of control versus working toward a goal. And the stock in this case, I said, was global temperature. Now, there is a stock of CO2 emissions. There is a stock of the amount of sunlight, I suppose. The water level you can think of as a stock, the ice levels and so on. But it's really the heat that's trapped in the earth and in the atmosphere and so on that's of interest here, that's driving all of these other things. So that was the answer to question number 2. This was a short answer question from the same exam. We have a grain elevator used for loading and unloading, and again, the grain elevator sits empty and it loads at a rate of 800 tons per hour for 2 hours, so that'll take us to 1,600 tons. And then there's no activity. Whoops. There's no activity for a while until 6 o'clock in the morning. And then the next set of rail cars come and they take stuff away at 400 tons. So it's going to take 4 hours to get rid of that 1,600 tons. And there we go. And it's important to understand that we're looking at the tons of grain, the amount of the stock over time. This graph down here is looking at rates. We have tons per hour. So again, something important to keep in mind if you see a question like this: what are they asking for? Is it the amount of the stock, or is it the the flow rate? Now in this case, we said that grain comes in at 800 tons per hour for the first 2 hours and goes out at 400 tons per hour down here. So we have those two lines on our graph. That was pretty easy stuff. Okay, and then we have a couple more final exam questions. Norway's talking about their quota for codfish, and the question is, which of the following statements is true about fish stocks? Fish are a renewable resource. If you have 2 fish, you can always get more fish. So this one can be eliminated, and this one can be eliminated. So we will do that. So we eliminated the non-renewable resource ones. So fish are a renewable resource. So we're down to B or C. Flow limited and stock limited. Well, we haven't really talked about that in class, but if you parse the words, it should be easy to figure out. Something like an oil well is stock limited. The amount of oil you can get out of it is based upon the amount of oil that's in the rock formation, so on, to begin with. That stock is limited, so it's a non-renewable resource. So this statement B doesn't make any sense. So the one that does make sense is statement C. Fish are a renewable resource. If you have, fish that are able to mate and lay eggs and all that kind of stuff, you can get more fish. The rate at which you get more fish is flow limited. So it depends on how many fish you currently have and where they are in their sexual maturity cycle and all that kind of stuff. But it's not stock limited. So that's a correct statement there. And we're looking at the fish as food upstream and the fish as food downstream kind of bits. Well, the plankton and so on coming in would be a source in our system diagram, and where the fish go after they're caught is a sink. So we would just depict those as little clouds in our diagram, and it would be good. Now, these system archetypes are the subject of another YouTube video, so I will let you watch that at your leisure. We're going to talk about bunnies in Canmore, and the stakeholder theory questions that we do here we'll be taking up in class. I won't include these in the video, but I will talk about the answers to these questions here. So we have a single stock system with two feedback loops like we've done multiple times in class. The rabbits in the story are the stock of interest. The culling and multiplying aspects of the story, so we take some rabbits out of the system, the rabbits that are in the system continue to multiply, and so on. This would be an example of a balancing feedback loop, so culling would be associated with balancing. Whoops. There we go. And multiplying would be associated with a reinforcing feedback loop. So the rabbits are multiplying. There we go. Connect those bits up there. So that was what we were looking for in that particular question. Okay, moving along. If we can consider the rabbits as resources, as food for coyotes and cougars and so on, what characteristics do they have? Well, this is the same as the fish question we saw moments ago. Rabbits are renewable. If you have two rabbits, a male and a female, you can always get more rabbits. So they're a renewable resource. And we're only limited by how many rabbits we have and where they are in their maturity and so forth. So this is a flow limited situation. Finally, limiting factors. Limiting factor in the rabbit rescue is absolutely everything to do with the availability of the sanctuary space. Now there's a number of factors at work. We have costs, we have management, we have political concerns. There's all kinds of things playing out in this particular story. And we have a system, we have elements, we have rabbits and coyotes and trappers and politicians and sanctuary people and all that kind of stuff. We can see the feedback loops, we discussed those above. We can see the interactions between these very different bits. The system's function or purpose, though, the aim of the system, to use the words of Edwards Deming and so on, is really the tough nut to crack. The least obvious part of the system is the function or purpose. Moving right along, the original approach, trap, spay, neuter, and so on, is going to cost real money to the taxpayers of the town of Canmore. And suppose we get almost all the bunnies, but not quite. And in a few years' time, the bunnies bounce back. Well, this is an example of a system's resilience. So you compress the system like a rubber ball, and boom, it's going to spring back up. So systems have resilience, and that was the property we were looking for. Suppose we have Canmore Community Gardens with carrots and other vegetables, humans and rabbits competing for the bounty of the garden. Guess what? Tragedy of the commons. And that's it for those answers, and I'll leave it here.